All right, looking at the video again on exploring circumference, and you guys remember you measured the arm spans of all your group members, and then you got together and made circles with 2, 3, 4, and 5 people, and measured the diameter and had the measure of the circumference with the arm spans. So what I want to do is just kind of go through and just make sure that you know what you're doing here. And I'm going to use statistics from last year because that's all I had with me. So we're going to look at 2 people with an arm span, and I'm using feet, 11.5 feet. I'm keeping it the same. I told you you guys could use centimeters or inches. So if you did that, you'll have to change your label here with feet, and then you'll have to change your numbers so that your statistics will fit in the interval. So back up here, 2 people, 11.5 feet for the circumference and 2.9 feet for the diameter. And then for 3 people, it's 16.8 feet for the circumference and 4.8 for the diameter. For 4, it's 22.1 feet and 5.7. And then for 5, 27.1 feet and 8.3. And so then it said to graph your points. I've already got a line here. I'm going to move that out of the way for a minute and plot our points, and then we'll look at that line in just a second. So the x-axis is diameter. So we're going to say the x-coordinate is 2.9, almost 3, and the y is 11.5, which would be about right here. And I'm going to label that 2, and I know you're really not supposed to use numbers. You can if you're going to use the ordered pair. I'm just going to use the number 2 to label it, so forgive me for that. Okay, for 3, it's 6, let's see, 4.8 for the x and 16.8 for the y. So that's going to be for 3 people. For 4 people, 5.7 and 22.1, about right there. And then for 5 people, 8.3 and 27.1. Let's say about right there, so there's 5. So now, it says make a conjecture in general. What do you notice about the points on your graph? What shape or pattern do they seem to form? Well, they seem to form a line. So we're going to take this line, and just so happens it works. How about that? So that's our line of best fit. We tried to get as many on the line as we could and as many above and below. This one might want to come up. Let's see, just a little bit that way, maybe. Touch those 2. Then we got 1 above and 1 below. That's not too bad. Okay, so when I look at that, I know I've got a line, and it goes up from left to right, which means as the x values increase, so do their corresponding y values. So now we're going to look down at the ratio of circumference to diameter. And when we look at the ratio, I'm going to come back up here to the chart because I've got room here to do it. So the ratio would be 11.5 over 2.9. So I'm just going to put my fraction bar right there. And we're going to divide those. I think, I've already done that. So when I take 11.5 divided by 2.9 in my calculator, I'm going to get 3.96. When I divide 16.8 by 4.8, I get 3.5. 22.1 divided by 5.7 is 3.87. And 27.1 divided by 8.3 is 3.26. Now, notice that these are all in the 3 range, so anywhere between 3 and 4. And that's no coincidence. When we look, also, it asks us to find the mean of those numbers. And when we do that, we have to add them all together. So we take 3.96, 3.5, 3.87, and 3.26. And we're going to add them for the mean, and then we're going to divide them by 4 because there's 4 of them. So that's going to be 19, 15, 23, 25, 12, and 2 is 14. So we're going to take 14.59, divide it by 4, and that's going to be 3, 25, so that would be the decimal point there, 8, 24, 19, so that's about almost 5. So 3.85 is our average. Now, that average is a little high, but again, part of the reason is, you guys were measuring your arms, and so that's going to be not quite, and making circles with those arms. So those probably weren't perfect circles, and we couldn't find the exact diameter. So there's a lot of factors that go into that. But if you notice, it's very close to the number pi, 3.14159.265, blah, 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 blah. So anyway, that's what we're trying to show here. And every one of these is the ratio of the circumference to the diameter, and that's what pi is. And we notice that we get numbers very close to pi. So as we do these last two problems, it says with a circumference of a circle with a circumference of c and a diameter d, the ratio of circumference and diameter, there it is, c divided by d is equal to pi. But it says use this to write a formula you can use to find the circumference of a circle when you know its diameter. So what they want us to do here is solve for c. So this is one of our, I can't think of the word, our, not implicit equations, but anyway, it's got all variables in it, and we have to solve for a variable. So we're going to solve for c, and we do that, we have to get c alone. Well, c is divided by d, so we undo the division by multiplying by d on both sides. Here I'm going to put d over 1 so you can see a factor of d in the numerator and denominator. d over d is 1, so I can divide out those d's, and I end up with 1 times c divided by 1, which of course is the multiplicative identity, which says c is equal to pi times d. So that's another formula. It's a very common formula that we use a lot. We also, you've probably seen the formula c is equal to 2 pi times the radius. Well, that's because here's the diameter, and the radius is only going to be half of that. So the diameter is the same thing as 2 times the radius. And we substitute that in, and we just pull the two in the r apart. And the only reason we do that is because mathematically, always in your equations, constants should go first. I'm sorry, whole numbers should go first, the coefficient, then constants, and then your variable. So now we're going to take this and we're going to solve this and find the circumference. So we're going to find what that length is all the way around. So we're going to say circumference is equal to pi times 4. And on the calculator you can do that. I don't have a calculator available, but when you do that you're going to actually press pi and not 3.14. We don't want an estimate. We want as exact as possible. So we're going to multiply pi times 4 on your calculator, and you're going to get 12 point something. And you can just round to the nearest hundredth, but it'll be more accurate than if you use 3.14. If your calculator's not set up to do that, we can figure that out and get your calculator so that when you hit 4 times pi and hit enter, you actually will get a number and not just the number 4 pi. All right, so let's move on to the next side. Get this up here. And now we're going to look at the side that you did at home alone, and we were just pretending that a student had an 18-inch string, and we had to go in and find the length and width in inches if they were holding it so that it formed a rectangle, and the two ends down here were 1 inch. We have to find the length of the other two sides, or then 2 inches, 3 inches. So if you had two people holding that string that's 18 inches long, what would it look like? So if the length is 1, then you're going to have a rectangle, and I'm going to do it sideways. It'll look something like this. It's going to have 1 inch here and 1 inch here. Well, in that case, if there's 18-inch perimeter, add up all the sides, we could subtract out these two, and we're left with 18 minus 2 is 16. Well, then if we divide the 16 by 2, I don't need to write that out, you know it's 8 and 8. So the width has to be 8. So if they're both 2 inches, then we're going to subtract 4, and we subtract 4, we get 14, and we divide that by 2, we get 7. And then if we do both, there's 3, we're going to subtract 6 from 18, and we'd end up with 12, divided by 2, and you get 6. So then you see a pattern here that goes down, and you can see you end up with basically the same two numbers down here, just one's the length and one's the width. So we're going to plot these points. So this is an easy one, and this one's going to be a nice straight line. So when we look at the width, that's the y-axis this time, and the length is 1. So we're going to go 1, 8, 2, 7, 3, 6, 4, 5, 5, 4, 6, 3, 7, 2, and 8, 1. And when we draw that line, we can see that line pretty easily. So again, we have a line, and this time it goes down from left to right. Okay, so this ratio here, we've got inverse proportion here because as one increases, the other one starts to decrease. So that's why it goes down from left to right. So we're going to now look at how is the sum of the lengths of the width of each rectangle related to its rectangle's perimeter. If we come back here, we know that we have two sides that are 1 and two sides that are 8. And if we look at those and we just look at the 1 and the 8 here, we know that if we add those two together, we get 9, and then if we double it, we get the 18. If we add these two, we get 9, double it, and you get 18. These two, you get 9, double it, and 18. So we can say that 2 times whatever numbers we have here, 1 plus 8, is going to be 2 times 9 equals 18. That's going to work for every pair of numbers down here. So we come down to 3, and it says suppose the rectangle has a length of L and a width of W. So now we're just going to say that the L is 1, or the 1 is L, and the 8 is W, because it'll work for all of those. Then we know on any rectangle, I can take the length and the width, add them together, multiply them by 2, and I can get the perimeter. Now, also, you might see the equation this way. And this may be helpful if one of the sides is missing. You could distribute, use the distributive property, so you could also see the equation 2 times L, bring to my plus, 2 times W, is also equal to the perimeter. So then down here, you're supposed to use that formula to find these perimeters. Well, 4 plus 6, I'm going to multiply that by 2. So I'm going to do 2 times 10, which is 20 inches, label. And then we have 9 plus 3, multiply that by 2, so 2 times 12 is 24 feet. This is very simple stuff. You've probably done it before, but we just want to make sure everybody's got it. So 2 times 10 is 20 centimeters. And that's it. If you need to rewind anywhere and go back and double check something, feel free. Have a good day.